Hi everyone, today we are going to build an analog or a physical map. As you will see, this is going to be covering Budapest again, and this is going to be a so-called string art or string map. These maps are based on a simple board where we hammer nails into following a certain outline, and then we connect these nails with a string in whatever way we wish. Of course, as everything in my house, this starts with a Python tutorial where we will plan the design and then we will execute the design and build the map in real life, getting our hands dirty. So before jumping to the coding part, let me show you how this map will look like. Now, let's see how this works out in Python and then in the workshop. So here's this website called Instructables. I didn't know this website before, but it seems like an art tutorial website or platform where I found this very exciting tutorial on how to create a string art map. And after reading it through, I realized I will need a few things. I will need a board, I will need nails, strings, and a few other things. And I also realized that I will probably need a template so that I won't just hit the nails in the board at random, but I will have a scientific way of figuring out where the nails should go. And first I will show you how I designed that part, which surprise is going to be in Python. And then I will also add a couple of footages which will show you how I built this string map. So let's go to the Python part. First, the usual imports. I also add the link here, just in case you want to read about string art or any other art projects. And then I queried the map of Budapest. So spoiler alert, here again I will create a map of Budapest. This time it is going to be completely analog. This is just the preparation work in Python, but I could even skip it and do it just by eye, but I felt it's more fitting to my style that I will have a blueprint made in Python. So to make it easier and a bit more realistically looking, I turned this data frame into the local CRS, but it won't be too much different in the longlet CRS, which is the default in OpenStreetMap, as we know very well. So then, what I want to do is that I want to extract the boundary lines of this object as a polygon, and then place a certain number of points, the nail points, along those boundary lines in a fairly equal or equidistant way. So first, I will need to get the geometry and also define the number of nails I want to use, for which I picked 50. Then we can get the outline very quickly by just taking the exterior coordinate series of the geometry. For later, let's also save the length, which now is measured in meters and it's the actual physical length, but we will be able to scale it down easily. Then we will compute the distance between nails. So these are going to be essentially the nail points already. And then we will need to turn these into geometries using the outline and its interpolate function. So this way we already have a series of geometry points, and soon we will visualize that. Just before that, some preparation for the plots, querying the boundaries and setting up the bounding box size to make sure that our visuals will fit any upcoming canvas size as well. So next, we create a figure. Here we will get a list of X and Y coordinates, which are going to be describing the boundary lines. make sure that the aspect ratio is set properly. Let's add a title. The end is going to be about 35 centimeters in both directions. So this is how the map of Budapest would look like. But the scales are still the original one, but don't mind that. And now let's also add the nail points using the scatter plot command. Maybe we can increase the nail size. Yep. We can even color them to be red and use even bigger markers. Yep, so these will be the nail points. So now we could move on and print it and start building the map right away. And that's what I will do, but I will also do some kind of simulation on how this should probably look like. So before the simulation part, let's see how we can prepare the map. I have this version of the visualization, which is pretty much the same. It just exports it in a large enough PNG object. And if I run it, then I will have the Budapest nails file, only with the nail points, which is going to be totally fine. And then I will have to print it. So the boards I found have a size of about 40 centimeters in both directions. So the 35 centimeter canvas size is realistic. However, I only have a regular printer, so I can only print in A4 size, which is fine if we use a magical tool Excel to print it. So let me show you how I printed this map or this template. So I opened Microsoft Excel, which I don't do too often, but sometimes it's very helpful. And it turned out that the easiest way to split or tile this image into multiple A4 pages is to use Excel. So once it's imported, I think that if we press Command P, then we can set the printing view, or maybe it was here by default. I'm not even sure, but as you can see here, probably you can see here, there are these dashed lines which show the boundaries of the A4 pages. So what I wanted to do is that scale up this image so it fits 2 A4 pages. And if it's stretched or scaled up, then I can go for the printing part. And here you can see that one part of the image is printed on the first page and the other part or the other half is printed on the second page. So if I do this, then, and you will see that I can easily match them together and cover most of the board which I have. So this way we can easily print an image, even if its size is larger than the A4 pages, my humble printer is capable of handling. But for now, let's go back to the Python part and see how this string map might possibly look like. Let's call this first part like preparing the print. And the second part, simulating the string map. So depending on how we start and what logic we use, so whether we start from one point and we start to connect that point to all the other points, or we do some horizontal or diagonal crossings with the string from one nail to the other, different patterns may emerge. So here I had a long chat with ChatGPT about what types of, let's say, string textures or like string layout designs may exist. And now I will show you the few ones that I found the most appealing. First, we will need to turn the nail points into NumPy arrays so that the calculations will be easier on the coordinates. And then let me add a bunch of functions. First one will be the random layout, where we connect pairs of nails at random, and this will create a chaotic, dense network of lines, pretty much like an Erdős-Rényi graph when it comes to graph theory. So this will be like a filled string structure where strings go in every possible direction. Then another one called polygonal string layout, where we connect each nail to another one that is a fixed number of steps ahead along the perimeter. Here the step size controls the geometric pattern, so smaller steps will turn into smoother perimeters, larger steps will result in much dense crisscrosses across the map. And this is very much the same logic like in network science, we can build small word networks following the Watts-Strogatz model. One that might also connect to mountain biking is the spoke layout. So here we will need to pick an anchor, and I believe that this was also the default this tutorial on Instructables followed. So we pick an anchor, a central node or nail, and then we connect it to all the other nails, which will create sort of a starburst or radial pattern, which is great to highlight certain specific points or features. Then there is this one called string cross, which connects each nail to its opposite point on the perimeter, which will produce sort of an X-shaped or patterned map, which can also be interesting, but you will see if our polygon is not entirely symmetrical, then it will lead to some even more interesting designs. Then I have a few more bespoke layouts, like the one called strings alternating. Here we will be alternating between two different step sizes, so it's similar to the polygonal, but here we will make one small step and then one large step. And here I also queried a very tricky one. I will copy the whole function here, which is gonna be called multi-spoke. So it's essentially the same as having the spokes, but here we will have multiple anchor points. So here we will be able to select a bunch of different points and then connect each of those points to every other nail in the map, and then see how they light up the nail map or the string map. So now let's see how these look in practice, because now this has been loads of function definitions. So first we define the canvas, then we put together a list of methods where we give the name of each method and also add the functions with proper or appropriate parameters. And once we have these things prepared, we will have to run a for loop which will iterate over the axis. So here we will have 6 rows of images, so we will iterate over each row, so each axis, and for each of them we will pick one element from the methods list, which will come with a title and the lines produced based on these input parameters. So remember, n is the number of nails or number of points we have, and then for each image we create a scatter plot which will show us where the nails are, and then we will iterate over all the lines and visualize them in a more subtle way. And then we do the usual formatting, final touches, and here as well. So let's see what happens. Yep, it runs pretty fast because it's some very simple NumPy computations. So here we have the random layout. The polygonal, there is something wrong here. Let's change the step size. Polygonal is here. Yeah, we have 50, but we have 50 nails, so that's a bit too much. And also this is not true. So yeah, this is how the polygonal looks like. It's pretty good. It's quite enchanting, right? Then this is how the spoke layout looks like. Honestly, I prefer the spoke layout to pick 2 points, one up here and one down here, so that we kind of capture the core location of the river Danube that splits Budapest in two, but also this looks very nice. This polygonals, it almost looks like this is a giant flower. Then we have the opposite cross, which is also interesting here. You see that the central part and like the center of weight emerges here. And here the alternating, which looks like a, I don't know, a brick-like flower. Then the multi-spoke, that's interesting and pretty dense. And yeah, I think that's it. In my notes, I also did some calculation on the total length of strings we will need, but I suppose that this kind of hints on what directions we would like to go for. Yeah, I'm not yet sure if I will do, yeah, frankly, I would want to do all of them and see how they look like in real life. But yeah, I will decide soon, and you will see in the rest of the video, which I will record a bit later, that which final layout did I pick. So keep watching the video because I will include the footage on how I put it together and how I built up this string map, how I prepared the board, how I hammered the nails and all that. So see you at the end of this video.